The deep sea is a dark place. Light cannot reach there. The water presses down like a heavy hand. It is very cold for most of the range. Yet in this blackness, there are islands of heat. These are the hydrothermal vents. They glow in camera lights like lanterns in fog. Strange creatures cluster around them. One of them has furry claws. The first scene feels like a secret. A pale crab sits on a rock. Its limbs move slowly and carefully. Fine hairs line its claws. Fine hairs line its arms. The hairs shimmer under the submersible light. They look soft, like wool. They seem out of place here. The sight makes one hold their breath. This place is large and empty in most directions. Food is rare in the open deep. Much life depends on a slow rain from above. Plant matter and dead animals drift down like snow. Hydrothermal vents are fissures in the seafloor. Hot water gushes out from beneath the crust. The water carries dissolved minerals and chemicals. When it meets the cold sea, it forms plumes and chimneys. These chimneys host complex communities. Many animals live only near vents. The Yeti crab is one of them. The vents are violent places. Temperatures change rapidly over small distances. Water close to a vent mouth can be near boiling. A few meters away, it can be near freezing. The chemistry shifts too: sulfide, methane. These chemicals shape the life there. The Yeti crab came into human view in the early 21st century. Cameras on a deep-sea expedition caught its pale form. Scientists named it Kiwa hirsuta. The name Kiwa references a crustacean deity. Hirsuta means hairy. The image spread quickly around the world. People were surprised by the crab's look. It seemed like a small myth made of flesh. Exploration required special machines. Human bodies cannot survive that pressure. They brought back film, samples and data. Those tools let scientists describe the crab's life. The first reports were careful and calm. Scientists avoided grand claims. The crab is small. The crab is pale. Its shell is smooth, light in color. The legs are joined. They move with slow, deliberate steps. The eyes are reduced and seem adapted to low light. The main feature that draws the eye is its claws. The claws are long, fringed with dense, silky hairs. Under microscope, they form a felt of fine filaments. The filaments increase surface area greatly. That extra area gives microbes more places to attach and grow. The arrangement looks like a garden bed. The body shape is not ornate. It has no bright colors, few spines or heavy armor. The hairy claws are the crab's key tool. The setae hold dense films of bacteria. The crab waves its claws like a gardener tends plants. It brushes them through the water to bring fresh chemicals. The motion is slow and regular, and it maximizes the flow across the hairs. When bacteria build up, the crab eats them. It brings the claws to its mouth parts and scrapes the film free. The mouth has brushes and mandibles suited to harvest soft matter, and the crab then swallows the harvested microbes. This behavior is active farming. The crab does not passively sit and hope food comes by. The bacteria get habitat and flow. The crab gets food. Vent bacteria are not like garden microbes on land. These microbes can use chemical energy from compounds like hydrogen sulfide. They are chemosynthetic. They turn inorganic chemicals into organic molecules. That process is the base of life near vents. Hydrogen sulfide smells foul to us. To many microbes, it is fuel. The bacteria oxidize sulfide to gain energy. They fix carbon in molecules the crab can use. Without these bacteria, many vent animals would starve. The microbes form the foundation of a food web. The water that the crab accesses is rich in these chemicals. By waving its claws, the crab exposes its farm to the flow. The crab's setae mimic vent surfaces, but in a mobile form. It carries its own rich microhabitat. Life at vents demands a careful balance. Life at vents demands a careful balance. Life at vents demands a careful balance. Too close to the vent and the crab would face lethal heat and toxins. Too far and the chemical supply would be too weak. The crab thus positions itself in a sweet spot. It finds zones where flow is strong enough for bacteria but temperature is survivable. The crab can move incrementally. It drifts or walks to adjust its spot. It shifts claws to parts of its body where bacteria grow best. This behavior allows the crab to manage both risk and reward. The balance is dynamic and continuous. Yeti crabs are often found near one another. They form loose aggregations on rocks and chimneys. These groups can look like small colonies. The clustering may reflect the best chemical spots. It may also help mating and exchange of microbes. Scientists have noted variation between males and females. Differences in size or claw form may hint at breeding roles. Other behaviors, like waving rates, might vary by sex or age. Evidence is fragmentary but suggestive. Being near others also changes local flow and microhabitat. A group can alter the chemistry just by presence. That can benefit microbes and crabs alike. The colony becomes a small community where life and behavior interact. The Yeti crab shows a simple truth. Life adapts with small changes. A tuft of hair becomes a garden. A crab learns to farm on its own limbs. The solution is neither grand nor flashy. It is practical and precise. In that quiet practicality, there is wonder. The deep sea is not empty. It is full of creative solutions to hard problems. The crab's partnership with bacteria is one such solution. It reminds us that life can exploit chemistry as well as light. As we study these animals, we learn more about resilience.